Hello, everyone. Yeah, my name is Jiang Xiaowei, so you can call me Xiaowei. Firstly, I should say thanks for the kind time arrangement because now in China it's close to the midnight. I'm going to talk about what we have done using the dHTC to extend our local HTC cluster at IHEP. And this report is on behalf of the computing team of FCC. So my teammates is also in the Zoom meeting. It's the outline. First, I will briefly introduce some motivations and the current status of our local HTC cluster. And then I will introduce the design and the implement of the dHTC at IHEP, and then the authentication stuffs, and then it's the interface and job environment. The last part is a summary. So why we don't do complete grid computing, but just extending our local cluster. This depends on the requirements from the experiments. Now we are hosting and attending in about 15 experiments. Most of the experiments are around the field of high energy physics. And most of the experiments do their data processing in the local cluster. Even there's some the domestic collaboration members, they're running small clusters. So we should consider to integrate these clusters together. Now we are facing a problem that we need to find more resources to the HTC cluster. So for these reasons, now we think extending the HTC local cluster is the better way to integrate and add more resources for the experiments. So first one is the experiments do their data processing in the local cluster for a long time, and their software, their data workflow is bounded with the local cluster. And most our users have been used to doing their data analysis in the local cluster, because for them, it's using a local cluster is close to use a personal PC, and they don't need to do some change their any habit they were used. And for access data and access the software, they can do it anytime and anywhere with the shared file system. And finally, some experiments, they don't have mature and official experiment software. So users write their own data process program in the different ways, but with the shared file system in the local cluster, it's easy to handle these things. So that's why we want to extend the HTC local cluster to find more resources for the experiments. And now we have these clusters and the sites in domestic China. Most of the sites are built with our help, and some sites and the data centers is built by ourselves. So most of the sites are built based on the HTCondor, because the high energy physics, most of the high energy physics jobs are HTC job. Some of the sites are the branches of IHEP. So we know that there are long-term resources provided by this kind of sites, but there are still some limitations on the network bandwidth and the storage. So some other sites are built by the collaboration members. So most of these kind of sites are the edge sites, so it's not big, just maybe small site. But the main problem is they have no pledged storage, so we have to consider about the data transfer. Then so the other sites are the cooperation institutes from the cooperation institutes or the universities. So there's nothing is pledged. The other resources are opportunistic. So we also need to consider about this situation. And so this size has different conditions. We know the different network quality, the different storage capacity, the different maybe the batch systems. So we need to, because it brings diverse requirements. We have to consider about it when we do the dHTC, when we design and then implement. Like for example, the resources including the CPU, GPU, ARM, and cloud. And they have different computing systems, different structures, and the job policies are different. So now here is the status of I have a local HTC cluster. Now we have SCADA clusters and main central managers, and totally now we have about 35,000 CPU cores. Most are the single core slot, but now an urgent task is to find more resources for the local cluster. From these two pictures, we know that there are always large amounts of jobs are waiting for resources in the job queue. In many time points, there are above 100,000 jobs sitting idle and waiting for the resources. And this is the resource utilization rate. We can know that they're always, so the HTC pool is quite busy. The empty work node not means there are schedule problem. It means we set some work nodes as dedicated work node for some specific applications. If we set these work nodes as a normal slots, it means the resource utilization rate will be close to 100%. So we want to added more resources to the local HTC cluster. Then this is our basic idea. We want to added more resources from other clusters or the remote sites. It's like just directly added the work node into the HTCondor cluster. So we keep we want the users can keep their old usage mode. They can interact with the computing system in a unified entrance. So because we have some experiences with HTCondor, so I think that we find that the solution is still based on the HTCondor. So this is what we should do if we want to implement dHTC to extending our local HTC cluster. So there are 4 works need to do. The first one is the gliding factory. So my understanding is that the gliding factory is to take in charge of producing the gliding jobs according to some predefined policies. And the second part of work is a gliding job. The gliding job is responsible for starting the HTCondor study and report the work node to the local HTC pool. And then is the authentications we use. Now we use the ID tokens and the Kerberos. Why we use Kerberos? Because we have in the local cluster, we have used the Kerberos as the authentication for many years, especially it's bounded with the AFS storage. And the last part is the user interface. So this is a simple factory workflow. We designed it like this. So there are a sentry to watch on the job queue. If there are user jobs submitted in, then the sentry will trigger submission. The gliding job will submit to the factory scheduler. Then the scheduler will send the gliding job to the remote site. When the gliding job started, the study will report it to the work node. Will be reported to the resource pool, and the user can use these resources. So this is some policies that I think we have two kinds of policies. One is for the resource and one is for the job. So for the resource policy, there are two kinds of resource policy. One is for the static. It's used in the self-owned and the pledged sites because these sites have long-term resources, and all the resources have been ready. And if the factory want to send the gliding job to them, the gliding factory can do it in any time. The second one is for the cooperation size, the cooperation size and the HTC cluster, because the resources from these clusters or sites are optimistic. They're just short-term resources. The size decides when and what resources will be reported to the dHTC pool. So it's dynamic resource policy. Then is the job policy. It depends on the job requirements and the site conditions. For the local HTC cluster, it has the same workload environment as the local HTC cluster. So all the jobs can be scheduled to the local HTC cluster. But for the edge size, especially the edge size without pledged storage, we have to choose the job with the small data transfer to this kind of size. And for the big size with large storage and good network, we can send the jobs with the large data output to this kind of size. So this is what we have done on sharing the local HTC resources to the local HTC cluster. My colleague Du Ran, she has do some investigation test on several solutions. So one is the flocking and one is the HTCondor. These two ways will bring a large amount of HTC jobs to Slurm. So it will bring too much pressure to Slurm, and Slurm cannot hold the typical HTC scenario. And the first one is the overlap. It will avoid submitting too many HTC jobs to Slurm, but I think it's not a beautiful way, because we have to start or stop the counter service on the work nodes frequently. So when we know the gliding way, so we know that it's similar as the overlap, but it don't need to stop or start or restart each counter service. It just run a gliding job. So now we are using the gliding to share the HTC resources to the HTCs. It's the simple workflow. So when we find there are HTC jobs submitted into the HTCondor queue, and then the submission API will submit the corresponding number of gliding jobs to the Slurm queue. Then Slurm queue will send the job to the Slurm work node. When the started, and the work node will be reported to the HTC pool, and the HTCondor will do the matchmaker and send the HTC jobs to the Slurm work node. Why we use this simple workflow is because I just said that the HPC work node and the HTC work nodes have the same environment with the same shared file system and the same user namespace. So for the remote sites, we focusing on one of the remote sites, the Dongguan data center, because there are many long-term resources there. There are about 30,000 CPU cores, including part of ARM CPUs. So the advantage of Dongguan site is that the site is belonging to the IHEP internal network. So, and the network bandwidth is dedicated. It's about 10 Gbps, and so it means we have more possibilities to handle the data access and the data transfer. if the job want to use the US, they just run the command US commands. If the job want to read or write files in the last tree, they just we just need to deploy the XD gateway on the remote work node. So this then is the gliding client has two parts. One is the gliding job and one is the submission. So we should prepare the gliding table. It's easy to find in the HTCondor YAML repository. And the only thing we did is to compile the ARM version HTCondor table, gliding table on our ARM machine. And the second part is gliding job. So it's a typical glide job. I think I don't need to repeat the workflow, sorry, the process. And then is the submission API. And so the next part is what we have done with the tokens. So before that, we didn't secure our HTCondor cluster for many years. We just used the claim to be. So it's not safe. Now we're using the ID tokens for the daemon certification, because when I go through the HTCondor manual, we found the ID tokens is suggested, and it's easy to configure. And it's easy to deploy, just to do some things on the configuration level. But for the Kerberos tokens, we met some problems. In the beginning, we tried to just to do the HTCondor configuration to deploy the Kerberos tokens, but it's failed. It seems the same user namespace between the submit side and the execute side is necessary. So if there's no same user namespace on the two sides, the shadow will be failed to create. So now our current solution is to transfer the token credential as a normal input file. We will use the job wrapper to initialize the tokens credential and eclog, run the eclog. So the next part is the user faces. We still use the HEP job to add more functions to fit on the dHTC. And we also do some job workflow stuff for the experiments to help them to using the dHTC environment. So I think I don't need to introduce more details about the Singularity, because here are all experts. So we also use the Singularity to package the operating system and the software. It makes the job can be independent from the environment in the remote work node. And here are two application cases. One is the lasso simulations. The lasso simulation has small input and not large output. But the job submission policy should be decided by the users, because just I mentioned on the background, the lasso experiment has no major common software, so the users have their own software in the personal directory. So in the local cluster, they can just access the shared file system, but in the remote side, there is no shared file system. They have to transfer their software to the remote work node with their jobs. But we still just provide a simple command, like add an argument -remote. And for the second application is the best simulation. They have a mature software framework. It provides the possibility to do a transparent schedule. Like we can easy to judge from the boss job, from the boss job operation option file, that we know the job type and where the data stored. So we can do some wrapper in the HEP job to have them to remap to have them to find what kind of jobs can be running in the remote side and do the data access. So here is the current status. Now we have run the ITC jobs in the extended HTC resources for several months, and we are still working on some specific jobs can run at the Dongguan site. For the last experiment, we have succeeded to run their WCDA simulation job and WFCT simulation job. And for the best 3 experiment, we are still working on that to find to transparently schedule the best 3 experiment simulation job to the remote sites. And we have planned to migrate all the experiments jobs to the remote sites by the end of this year. This, I think I have no time. So this is something we did on the ARM machine. So what we have done is we compiled the HTCondor gliding table on our ARM machine, and we managed to report the ARM resources to our global pool via the gliding job, and we have the experiment to compile their software, and we can succeed to run the large-scale Corsica jobs in the dHTC pool. So this is the summary. By extending the local HTC cluster, we added more resources for our experiments, and now with HTCondor gliding, we have made a basic design of dHTC at IHEP with the HTCondor gliding. Now we have extend 2 parts of resources added into the local HTC cluster now and served in the production. One is the HTC cluster and one is the Dongguan site. And now in the future, we will implement a complete gliding factory, because now we only have a simple design of the factory and just implement a simple workflow. So then we will make the whole process more automatic. So then the second work we will do is to introduce the dHTC to more experiments and have them to migrate their jobs to the dHTC resources. Now we are still facing some problems. So one is the Kavros tokens. So we just transfer the tokens to the remote work node, but we didn't do the renew and prolong. And then we need to find a better way to access and transfer data, not just using the HTCondor transfer mechanism. So that's all of I have. So thanks. Thank you for your time. Have any question or suggestions?
Thank you very much, Xiaowei.